Pick up a screwdriver, steel shaft, plastic handle, it costs a few pounds. It feels simple, but that screwdriver is one of the most complex objects on Earth. Not because of what it is, but because of everything required to make it possible. Let's start with the metal. Steel begins as iron ore. Iron ore had to form deep inside the Earth over billions of years. Geological forces had to concentrate it into mineable deposits. Then humans had to discover it, learn to extract it, invent smelting, build furnaces, control carbon content. Steel is not just melted rock, it's controlled chemistry. But mining iron requires excavators, drilling rigs, explosives, haul trucks, rail networks. Each of those machines requires rubber tires, glass, hydraulics, electrical systems, computer chips. Already, your screwdriver depends on metallurgy, mechanical engineering, petrochemicals, semiconductors, global logistics. And we haven't even touched the handle. Plastic begins with crude oil. To get crude oil, you need geological surveys, seismic imaging, offshore platforms, deep-sea drilling technology, refining plants. Each offshore platform is a floating industrial city. It requires precision welding, advanced alloys, satellite navigation, weather forecasting, global capital investment. Oil becomes polymers. Polymers become plastic pellets. Plastic pellets are injection molded into a handle. To mold plastic, you need injection molding machines, precision dies, temperature control systems, electricity. Electricity requires power stations. Power stations require turbines. Turbines require precision machining requires micromechanics. Now your screwdriver depends on energy grids, global finance, materials science, industrial chemistry, satellite infrastructure, all for something you leave in a drawer. The screwdriver is not handcrafted. It is stamped, hardened, machined, finished, packaged. Those processes require CNC machines, heat treatment furnaces, robotics, conveyor systems, quality control sensors. CNC machines exist because, centuries ago, engineers learned how to cut gears with extreme precision. The Industrial Revolution refined tolerances. Watchmakers mastered miniature precision. Micromechanics taught us how to control friction and alignment at tiny scales. Without that heritage, modern manufacturing collapses. The screwdriver is the visible end of an invisible lineage stretching back to the first controlled furnace. Behind every screwdriver, a miner in Australia, an oil worker in the North Sea, a semiconductor engineer in Taiwan, a logistics coordinator in Rotterdam, a software developer maintaining supply systems, a banker financing infrastructure, a satellite orbiting Earth enabling GPS tracking. Millions of people, thousands of companies, hundreds of technologies, all synchronized. You are not holding a tool. You are holding a global civilization. Now ask yourself, could you build a screwdriver from scratch? Start with iron ore in the ground. Refine it into steel. Drill for oil. Refine it into plastic. Build the machines required to shape both. Generate electricity. Transport materials across continents. Individually, no one can. Not a billionaire. Not an engineer. Not a nation. Because modern objects are not individual achievements. They are collective intelligence made physical. This is both terrifying and extraordinary. Terrifying because it reveals how interdependent we are. Extraordinary because it reveals how powerful cooperation is. The screwdriver is simple. Civilization is not. And the more advanced our objects become, the more invisible the network behind them becomes. Next time you pick up a tool, pause. It looks ordinary. It is not. It is the accumulated knowledge of thousands of years. Metallurgy, chemistry, mechanics, energy systems, trade networks, Mathematics, physics, layered, compressed. Into your hand, you don't own a screwdriver. You borrow it from civilization.